Hello, once again, you are welcome to our webinar on IoT infrastructure and overview. My name is David Gowu from the Institute of ICT Professionals, Ghana. Our resource person is Mr. Samuel Adranyi. He is a Microsoft MVP and also a senior software developer with Andela. Today, we'll be going through the infrastructure of IoT, and Samuel will take us through. Samuel, welcome, and let's get going.
Thank you very much. So my name is Samuel. I'm going to kick started with this. Hopefully at the end of the session, you should have a clearer idea of what IoT is and the infrastructure that supports IoT. And I would, if time permits, I might show a demo if time and logistics permit. And then also I will try as much as possible to demystify any gibberish myth or thing you might probably heard or you think you know about IoT. So let's get right into it. So I'm Samuel Adranyi. I'm a Microsoft MVP on the Microsoft Azure Technologies. I'm also an MCT and an Oracle certified professional. Currently, I'm a senior software engineer at Andela and also CTO for my own startup called IIPGH Solutions, where we deal with data analytics and smart systems, IoT as well. I am an IoT, AI, and cloud solutions architect. I'm a community lead, so I'm one of the leads for the Accra.net user group and then the Accra Power Platform user group. I stream 3 times a week. On Tuesdays, I talk all about IoT, demo IoT, create IoT solutions. And then on Fridays, I demystify technology, be it any technology in the cloud, AI, IoT. I try to demystify and make them clear. And then on Sundays, I stream about the Microsoft Power Platform, which is called Power Series. I also host a podcast, which is called Control Escape, that drops every Friday, and it seeks to interview Africans across the globe that are into technology to share their ideas and share their experiences. So below are my social links, Adranyi on LinkedIn, Twitter, Skype, GitHub, Medium, all of them. You find me there. You can also check out my website, that's sadranyi.me. All right, so let's go on to today's agenda. So I'll first of all try to explain what IoT is. We'll talk about a short history and evolution of IoT. We'll take a look at some applications of IoT, and then we can look at the infrastructure and technologies that are backing and supporting IoT. Then I'll try as much as possible to also, I'll talk about some concerns of IoT, and then we'll look at some of the adoption barriers. And then if there's time, or if my setup permits, I'll show you a very simple demo of some uses of IoT. So let's get in. So first question always we get asked, what is IoT? There are multiple explanations or definitions and clarifications for IoT is. But to put it in the layman's term or layman's understanding, it's basically, first of all, it's a network of internet connected objects. And here, objects, you see pretty soon why I mean objects, that are able to, first of all, collect, exchange, and act on data without human intervention. That is in a nutshell what IoT is. Now, it's a network because it's interconnectivity of multiple objects. Now, we said internet connected object because it could be your connected glasses, it could be your connected microwave, it could be your connected car, it could be your connected air condition, it could be your connected shoe, it could be anything that has internet connectivity can be part of the big network of IoT. And that's why I made it object. In some places you hear connected things or devices or computers, but these are all objects. Any object that has internet capabilities or that you can make internet capable can be part of the whole IoT system. And just to clarify that, maybe this simple illustration would help understand. So technically, any device, okay, it could even be things, it could be even a human, all right? And then that is what, and it could be anywhere in the world. It could be run by businesses, and then it's part of this big network. Now, we'll talk about some of the network topologies that support it in the infrastructure later on in the presentation. And then these are things that run anytime. So they're running 24/7. So, and most of it is not human determining. So these are just a basic understanding of what IoT is. So today you know that it's basically a network of interconnected objects that is able to collect, exchange, and act on data. So let's do a little history of IoT, where it all started from. Now, people think IoT just, sprung up from somewhere all of a sudden and it's a buzz and all that. But it will interest you to know that Coca-Cola, the first Coca-Cola vending machine, that is as early as in 1982, was termed to be the very first IoT device because it was internet connected, and it was able to report its inventory, which is the number of Coca-Cola product in the vending machine, and it was also able to tell whether the drinks were cold or not. Now think about this. This is 1982. There's even been proponent and a lot of things even way before this very first one. So and to keep all myths that IoT just sprang up from somewhere. No, that's not true. IoT has been around for God knows how long. The only difference is that then, as you know, the evolution of computers, they started really huge, ENIAC, huge, that you needed a kind of like a complete apartment to have it. But then as time went on, components and processors and silicons and stuff, microprocessors became much smaller, much cheaper, and much effective. The sizes started reducing and became more accessible to people. It's the same thing with IoT. When it started in those early years, the infrastructure to support IoT was quite huge, expensive, and was not easily affordable to the average or common person. But over time, it's just that in recent times, with the evolution and evolvement of technology, processes, tools, and internet, now it's becoming more accessible and more usable by even the ordinary person. That's why now you're hearing a lot more about it. So where does IoT fit in this entire revolution of ours as humans? Now, if you look closely on the scale, or what now we are terming as Industry 4.0, which is like the latest generation of industries that's supposed to mechanize or run the world, you realize that it started from factory automation or process automation. Then we moved on to like big data, we're collecting data. Then cloud computing came around. Then once we had cloud computing, there was this whole thing about autonomous system. You're talking about autonomous factories, autonomous cars and all that. Now, if you look closely, IoT is the next thing that is to change that whole industry revolution. All right. And then you have data management that is coming. That is because with IoT, there's a lot of data that's going to be generated. I'll explain why in subsequent slides. There's a lot of data that's going to be generated. And therefore, the next step after this is how do we manage this data effectively and make meaning out of it? So let's take a look at some projections that have been made by IoT. Now, it is projected that the number of IoT devices will grow from 7 billion, that is like 2 years ago, to 22 billion by 2025. I mean, so that's a lot of devices coming up. It's actually like doubling and tripling as we speak. Now, there's a market research, done by Gartner that predicts that this year we're going to have 26 times more connected things than people, which is true, because we've seen the adoption of wearable technology, we've seen adoption of smart clothes, smart devices, a lot more coming onto the scene. So we are looking at 26 times the growth of even more than people. And then there's also this kind of like research that states that now every second there's about 127 new devices being connected to the internet. It could be from your connected microwave that Amazon has done, that is even Alexa capable. You can talk to the microwave. It could be your Philips Hue bulb that you have in your house. It could be that car, that new car you have that you can press a button and the car, it started and it's getting warm before you getting. So every second we're talking about 127 devices being added. Now, where does that put IoT on the marketplace? Well, this is it. By 2021, we're going to be looking at 520 billion in terms of the IoT market. So a lot of money and investment going into it. Just to give you an idea of the various areas where this adoption or this projection is happening, take a look at this. So from the segment, and this is as far back as 2 years ago, but it's evolved now. So if you look closely, For smart cities, that's a higher adoption, because that's what we're seeing a lot more use of, IoT, from like home automation, smart lights, street lights, smart parking, things like smart healthcare and all that. But if you look closely, if you look at the details, it is being topped by America. So it is being topped by Europe, followed by America, and then the rest. Now, if you look at Africa, we quite, very, 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 very negligible. So that tells you that there is also a lot of opportunities in all these sectors for IoT on the continent. And therefore, if you are thinking or looking into going into it, this would be the right time to equip yourself to, empower yourself to and position yourself to, tap into this billions of, dollars of investment that is going to go into this sector. You can also look at connected industry, which is the second one. Then we can talk about connected buildings, connected cars, smart energy, which is like 10%. Then other stuff is like 8%. Then connected health, we're looking at 6%. Even smart agriculture. There has been a lot of smart uses of agriculture where herds are tracked by IoT to know where they are, to know their vitals, to determine if the herds are sick or in good condition. And then even smart retail. So there's a lot of applications of IoT in the various sectors around us. Now let's deep dive into these various applications so we can learn more. So there's one thing you need to know. There's an extensive set of applications for IoT devices, okay? But we usually divide them into what we call consumer, commercial, industry, and then infrastructure spaces. So let's take a look at in the consumer space. All right, now in the consumer space, this is one of the growing portions of IoT where devices are created for. So you're talking about home automation, like you have Alexa in your home, you have Philips Hue bulb. We can talk about connected vehicles. You have like Fitbits, you have like smartwatches, smart stuff. And even interestingly, you're also looking at some form of connected health. Now there are like health devices that anytime you take your pressure readings or blood pressure readings, it sends it to your healthcare provider, and they're able to track, day by day, whether one, you're doing it, and then whether you are staying healthy. All right. Then so there's also the use in application for remote monitoring. Sorry about that. Okay. Now, then let's take a look at the commercial aspect of it. Let's talk about the commercial aspect of it. So for commercial, you're looking at things like medical for healthcare, or what we call the Internet of Medical Things. Now, almost majority of the latest generation of bioinformatic or healthcare or medical devices, some way, somehow have got some IoT in them. For example, they are able to tell their maintainers that, oh, within the next after the next 5 surgeries or usage, you need to probably replace this equipment. It's going to tell whether the equipment is in top shape for you to use for a surgery. These are all smart innovations. Then we can talk about transportation. Now, elsewhere in other parts of the world, vehicles are very smart in terms of even communicating traffic with the vehicle. So the vehicles can actually determine an optimal path to flow. Now, I'll give you an example, which I know has been done in the US with some of their emergency vehicles, like ambulances or police vehicles. Now, they have sensors and IoT enabled capabilities that when a police vehicle and ambulance is approaching a traffic light, and that traffic light is red, they have smart systems that enable the presence of that ambulance or emergency response vehicle to change the flow of traffic in favor of that emergency response. So you might see that you might be in traffic, and once you hear a siren coming, automatically your lane of traffic turns to green just to allow the flow of traffic. This is how it's being used in terms of communication for transportation. And it uses some. Yep.
Samuel, so
Yeah.
in our case here, can we also
Yeah.
have a situation where, for example, in the morning from Adenta to Accra, traffic is so high, whilst from Accra towards Medina, it's very low. Can we have a situation where with this smart, system, we can have more flows, or the green lights would take more time for those flowing from Adenta towards Accra, whilst those moving from Accra towards Adenta will slow down. Is this something like that?
Absolutely. And I'm not supposed to disclose a lot, but there's work in the pipe to do this, to enable this in the country. And I was privileged to be part of I was privileged to be part of that meeting. So I can tell you there are plans underway, but yes, it is doable. However, there are some infrastructure requirements. Like for instance, the circuits on which our traffic lights are on are not the smart circuits. So it would require most of our traffic lights to be changed, or the circuitry to be changed to allow for that such control. But I know there are talks like that. So definitely, yes, you know, I mean, in phases we can see that happening. I mean, we can even take that back even to the consumer in the area of consumer IoT. For instance, with your if you have most of you, if you have Gmail account, right, and you commute to work within a particular time, if you realize at some point Gmail or Google on your phone start to prompt you that, you know, it's time for work, and it tells you even traffic conditions, you know, on the road. And then when you're at work and it's like, if you leave work at, let's say 5 and it's 5 o'clock, you probably see that Google also pops up again to tell you the commute back home. Now, these systems are interrelated. For instance, I'll give you a scenario now where the use of what we call beacons, Bluetooth beacons that allow our phones to actually communicate with the world around it. Now, they have been used in smart ways. For instance, if I have, let's say, a meeting, let's say I have an interview at 7 p.m., sorry, at 7 a.m., all right, let's say downtown or in the middle of Accra. Now, thanks to IoT, having access to my calendar, all right, and also having access to traffic conditions, right? And let's say I'm wearing a Fitbit that knows whether I am sleeping or awake, all right? All these things correlated. It knows that because of traffic and where I am, it might probably take me 2 hours to get to my meeting destination. And therefore, the Fitbit or whichever smart wearable I'm using, knowing that I'm sleeping, will probably wake me up around what, 4:30 or 5. Do you get it? So that I can prepare and make it to the meeting in time. This is even in the area of.
I don't need to even set an alarm. It will check
No.
When I should wake up, I should get on the road so that I can get time.
No, and this is the power of IoT that we're talking about, even in the consumer space. So all your Fitbits and all the smartwatches you wear, they have vibrations and all that. And they're also tracking your sleep pattern, whether you are sleeping or awake or talking and all that. I mean, even in that area as well, assuming that for all this, we're in a time of COVID, unfortunately, but I would use this example.
Hello?
Assuming we gave all this suspected cases actually a Fitbit or a device, right? And they were being tracked by the health services.
Like a wearable
Exactly.
On their
Exactly. So because we are tracking their vitals in real time, we can actually tell if their condition is critical for us to move them in, you know, or just continue home treatment. And this is actually has been implemented in the US, where a company, I keep forgetting the name of the company, but they are also into into wearables. Now, what they have done is DS is a ring. You know, Fitbits are like watches, but DS is a ring that has all the sensors in it. So it also tracks your sleep, your vitals, and your body, everything about your body. It tracks that. They have partnered with an AI company, and what they do is that they collected data from early stage COVID patients, all right, and they tracked their body vitals, and they created a unique signature or map, so that if you are using the app and you have that ring, you answer questions every morning, and it takes your vitals. It's able to compare your vitals to someone who had COVID. And this application now is able to predict whether you're going to get COVID as far as 24 hours ahead of time. So these are some of the, you know, the use cases applications between consumer and commercial use for IoT. So I was still talking about the commercial, where we can also talk about vehicle to everything communication. I'll give you an example of that. where emergency vehicles are communicating with traffic lights and other vehicles, you know, around it. Then we can talk about IoT's application for industry. Now here we call it industry IoT. Now here we can talk about manufacturing. So you have like manufacturing lines that are all IoT enabled, that are able to report the state of production, that are able to report the health of, let's say, the machine that is let's take an example of, let's say, Coca-Cola. So the machine that is capping the bottles, right? IoT sensors in it allow it to send its telemetry to the operator to tell it, I am too hot, I am too cold, and therefore what do I do? All right, that's another example. Then we can talk about agriculture. Agriculture, we have smart agriculture, in the sense that we have places where they were reliant on rainfall. At least now we are going into irrigation. Now with IoT, what happens is that you're able to take we can put sensors in the soil all around the farm that can determine the moisture level in the farm and determine what time is the best time for you to irrigate your farm. Right now, people are doing irrigation based on, you know, mostly based on manual assessment, or they have a time. They say, okay, make sure you irrigate in the morning, in the afternoon, and the evening. All right, that might not be efficient, but with IoT sensors in the soil, you are able to determine, is there enough moisture in the soil? If that's not the case, then it means that I need to water again, and therefore trigger pumps to start to let the water flow, or, you know, as in irrigate the farm. And this has been done hugely in America and Netherlands, in other places. Another example, like I mentioned, was for people who do like cattle rearing and all that. They have sensors that track the herds everywhere they find themselves, and then also they have, you know, sensors that is able to actually tell the vitals of the cattle whether it needs attention or not. So these are some of the industry applications. Then we can talk about infrastructure. All right, now in the areas of infrastructure, we are looking at energy management, we are looking at utility management, we are looking at metropolitan scale development, we are looking at environmental monitoring. All right, so like today, if our country was implementing IoT, all right, the water company and the electricity company, even though they have smart meters, they'll be able to tell us the exact amount you're consuming. They'll be able to, you know, like right now, for those of you who have smart meters, at least you're able to buy credit remotely, and that reflects on your smart meters. Those are examples of industrial IoT. Those are typical examples of industrial IoT. So as you can see, from your cars, from your homes, from your farm, you can use IoT in multiple and endless applications, right? Now,
okay, okay, please. You know, with our webinars, please, if you have any questions, please either raise your hand or just unmute and then interrupt the presentation, and then your questions will be answered. You don't need to wait till the end. Okay, please go on.
Okay, awesome. So, with the understanding of all these use cases for it, let's take a look at, you know, the network, the infrastructure of it, you know, the core, what makes IoT, you know, possible. Now, there are many technologies that enable IoT, many, and I know by the time I'm done, we're going to have some divergent views, but trust me, I don't think we need those right now. Now, to kick it off, we're going to talk about Bluetooth mesh network, or Bluetooth low energy, all right, which is just a specification that provides a mesh network that allows for increased number of nodes to be connected, right? It enables IoT. An example will be communication between devices using just Bluetooth. That's one thing. Then we can talk about, you know, light fidelity, just like Wi-Fi, but this one, the communication happens, you know, through visible light. So scientists have been able to discover that we can pass data through visible light, and that's Li-Fi or light fidelity. It also, you know, allows for communication between smart devices or IoT. Then we can talk about NFC, or what we call near field communication. All right, this is a communication protocol that allows two devices to communicate within like a 4-centimeter range. All right, and then we can talk about radio frequency identification, or RFID. All right, which uses electromagnetic fields. All right,
is airdrop? Hello, is airdrop one of the application of the near field communication?
So no, airdrop has a longer range. AirDrop
Right.
I would say it's kind of like a proprietary thing, either leveraging on Bluetooth, but then wrapped around Apple's own proprietary stuff. But that one is a longer range.
Okay.
NFC is very, very short. It's a very short range stuff. Now,
Okay, Cyril want to ask a question. I remember NFC was implemented by Samsung earlier on. I don't know whether they still have it.
Yeah, it's still on the phones. You can almost all recent or modern Samsung phones have NFC capabilities.
Right. Okay, Cyril, please come on with your question. Yeah. Unmute and talk, please, Cyril. We cannot hear Cyril. Cyril,
okay, sir,
we cannot hear him.
Okay, please, I wanted to know some examples of the Wi-Fi so that we can relate to what like is going on. Some examples like in reality so that we can see how things work.
So you technically cannot see Wi-Fi just the same way as Wi-Fi works. All right. There's an access point or a hotspot that is Wi-Fi that's running on Wi-Fi where you connect to. It's the same thing, just that this time around, Wi-Fi uses light. So where your access point in a traditional Wi-Fi will be like a router sitting on your desk, it might probably be a bulb you just connect inside your bulb holder. All right. And that is how, so it's using that to emanate the data between your devices, and then it will be available for your phones that are Wi-Fi capable to connect to. I don't know if that answers your question.
Okay. So please, with the Wi-Fi, is it only for internet access, or it can be used for maybe file sharing and other items as well?
Oh yeah, it's a communication protocol. So whether it can grant you access to the internet, it can grant you access to transfer and communicate between devices and objects. So yes, not just internet. It works the same way as Wi-Fi works. It's just that this time around, it's not coming from a router like as in a regular Wi-Fi router. It's coming from a light bulb, and not just any light bulb, a specialized light bulb.
Yeah. I've observed this before. I've seen this setup before. But the only thing is that if there's any shadow or anything that blocks the light, then the sound will stop.
Yeah, so there have been improvements in the technology where they are actually working on, it's just like Wi-Fi. If you place your Wi-Fi router, behind a very, very thick wall, the waves or the flow doesn't go to the next room or the next space, right? Because there's an obstruction. It's the same thing with Wi-Fi, so low or less lit areas do not allow the transfer of data or the communication. So there are, definitely, companies and things are still, researching and looking into how to overcome those challenges.
There's also a hand up. Ruben
Sure.
Want to talk. Ruben, please go ahead. Unmute anytime. Unmute and talk, please. Unmute. If Ruben is not available, then we can take Michael.
Yeah, hello. Thank you very much, Mr. David. I've seen the light having sound system being like just a light bulb playing music and connecting Bluetooth. Is that an example of the Wi-Fi, or is different from the Wi-Fi?
That would be a different thing. That would be different. Let's see if I can, just for the sakes of okay, so just for the sakes, I don't know if you can hear this, but I'm going to bring a video in view, and can you hear it?
Yeah.
Lights in our homes, offices.
Yeah, we can actually hear the sound.
And street lights, connecting us to high-speed wireless internet. Li-Fi is high-speed, bidirectional, fully networked wireless communication, allowing us to give the light we use to illuminate our spaces another purpose: connectivity. Li-Fi enabled LED lights modulate illumination levels to send data like
The sound is gone. The sound is gone.
be part of the light revolution.
Okay, so sorry about the sorry about the sound of that last portion, but I don't know if it helped if you got what the video said, and it gives you an idea of what Li-Fi is. Does that help?
Yeah.
Okay, awesome. Are there any questions?
Yes. Blessing want to ask a question.
Sure.
Blessing, please unmute and ask your question quickly.
Okay. Yeah, good morning.
Good
Please,
morning.
can you? Yeah. My question is, given that the IoT hold a lot of interesting advantages to people, so which of the infrastructures can give us the highest range of connectivity? And
So
secondly, what are the possible health hazards, given that some of the devices emit some kind of frequency and some other stuff? So what are the possible health hazards using all these devices and connecting to everything everywhere?
perfect. Good, perfect question. I was actually expecting this
Okay.
sooner than later. Now, communication as it's where today, radio communication is radio waves. All right.
Yeah,
Now,
yeah.
there are different spectrum or frequency or wavelengths that all these communications happen. All right. For instance, the way you get your radio, right? The transmission for your radio, transmission for your TV, the
Yeah.
reception for your phones. Now, these are all
Yeah.
radio waves in a particular spectrum. Now, some of these things are they are not visible to the naked eye or even, audible to the ear and all that. So you don't see or, perceive it. But the truth is, whether we like it or not, these things are there to, to make these technologies work. However, some of them at certain frequencies or levels are harmful, and most of them
Okay.
in the frequencies they are operating in are less harmful. Do not affect you. Now, there is something we should understand: the human being, okay, the composition of our body is a water mass. Is that okay? It's a
Okay.
large water mass, and therefore some of these things, either go through us or just stay at areas in our bodies that it's not that harmful. However, it's just like everything you overexpose yourself to. We know that the sun, also contains radiation, right?
Yeah.
Exactly. Now, these radiation are not harmful to us every day as we walk through the sun. Is that not it? Because the levels at which they hit us, our bodies can
Yeah.
take that. It's not that. But they tell you that if you overexpose yourself to the radiation of the sun, that could be dangerous. Do you get it? So it's the same thing
Yes,
in which
please.
all these devices operate. So they're operating in different frequencies and are not that harmful to us, as we use them day by day. But prolonged exposure, prolonged use of it,
Yeah.
okay, is where you have, a possible health hazard. And let me take this opportunity to, once it's being asked, it's going to come up actually, it was going to come up in part of the network connectivity. This whole foolishness, sorry for my English, but this whole foolishness of 5G linking to coronavirus, please, it's a myth. It is neither here nor there.
Okay.
Please, let's keep the technology, you know, and if you care to know, 5G works in a different spectrum. It works between 24 gigahertz and 100 gigahertz. It's like in the high frequencies, all right? And at that high frequencies, they have shorter wavelength. If you've done physics, you've done it. It's true for every waveform. So they have very shorter wavelength. Now, how many of you have microwaves in your homes? I'm sure most of you have microwaves in your homes.
Almost everybody. Yeah.
Exactly. Yeah. Have you wondered how you put stuff in the microwave and it gets extremely hot in the microwave, but not outside the microwave?
Yeah.
Yeah.
Microwave, it uses also, it's a short waveform.
Yes, 2.4 giga, 2.4 gig.
You get the point. So, and it doesn't come out. It's the same, almost the same frequency that, you know, 5G is going to work on. So it's a shorter, so it doesn't even penetrate your skin. It doesn't, so 5G waves doesn't penetrate your skin. And the infrastructure, since we're talking about infrastructure for IoT, and 5G is actually one of the driving, 5G is going to be one of the driving force in the future of IoT. So I can talk about this. Now, the infrastructure for IoT, because the wavelength for 5G is very short, to deploy a complete 5G solution requires a lot more infrastructure. Currently, the telecommunication mast you are using that we use for 4G and 3G and all that, you can afford to have a mast maybe kilometers away, and that can serve people in that area. It is not true. It is not the same for 5G. For 5G, they will need a lot of nodes, what we call nodes. They will need a lot of nodes to create a 5G mesh. So also automatically to 5G infrastructure is very, very, very expensive. And deploying it is not going to be a 1 day or 2 day or 1 year affair. I mean, researchers have even put that for countries to go fully 5G, it might take between 5 to 10 years. Because the equipment are expensive, you need more equipment to cover a smaller mass area, unlike 3G and 4G, all right? So just to debunk that, yes, there's always health risks associated with any form of radiation. That is even why they tell you X-ray, if you go to the hospital for X-ray, that is why they don't even encourage taking multiple X-rays, because they are shooting rays or radiation into your body. Does that make sense? So
yeah,
every form of tech, every form of communication in the spectrum, overexposure to it has some risk, but normal use, no, there's nothing to worry about. So please, let's debunk that. Sorry to say again,
thank you, Samuel, for reiterating the same, because we had a webinar on this last week. On Tuesday, I also spoke about this on CTFM, and we try to help people to understand. The first group of people who we are trying to help them to understand this are professionals, because people will always consult them to find out whether what is being said in the public domain is true or not. Yeah. But as you've rightly explained, again, to the details, 5G does not ordinarily cause you any harm.
At all.
However, if I should go naked and stand in front of a 5G antenna for maybe the next 24 hours, of course, the power, the rays that will be coming from there will have an impact.
Will hit you directly, yes.
Yeah, you know. But it's just like the way you have your Wi-Fi.
Please,
you know, there are some Wi-Fi.
Hello.
Hello. There are some Wi-Fi that are operating in the higher frequencies. Yeah.
Oh, my internet. Hello.
We can hear you.
Yeah, we can hear you. We can hear you.
Yeah, Mr. Samuel, thank you for that. But please, another of my question is this: since most of the devices are for gathering of data, and it's like it's connected devices gathering data. So that means the data is going somewhere like a server. There is a server somewhere taking all the device, the data from the device. So what is the, how is our privacy protected using the IoT devices?
I will talk about that in some of the adoption challenges. So I will address that when I get to that section, but thanks for that question.
Okay, thank you very much.
All right, awesome. All right, so
okay, let's continue. Well, sorry that we still have some 2 hands up.
Okay, let me take those questions and then we can move on.
KB wants to ask a question. KB, please.
Yeah, thank you so much. It's still about 5G. You know, you made mention of its lower penetration effects and high infrastructure, like the physical infrastructure, so that it can really go far. What if the transmit power is increased? Won't it increase its penetration effects and also help to reduce the infrastructure, the number of infrastructure that will be needed to, you know, spread it?
So to answer that, like I mentioned, it is the wave, it is the spectrum, the frequency spectrum that it's operating. That spectrum is a shortwave spectrum. So even if you boost or you do whatever it is, it's still that shortwave spectrum. It won't go beyond that length. It's a characteristics of waves in that frequency. Does that make sense? So it's by
so
nature of it.
Like David just said, if you decide to go naked and stand in front of it for, let's say, 24 hours, it may have an effect on you. Assuming the transmit power has been increased to a certain threshold, and you, instead of, let's say, being in front of it for 24 hours or being around it for 24 hours, then it means that if you are around it for, let's say, 1 hour, or you are in the vicinity of it for 1 hour, you can also have some effects.
Yeah, so
it is like relative distance.
Yeah,
it's like relative distance. Okay, even if let's say let's say this. Let's say the highest threshold for the whole 5G wave is, let's say, 100 meters. All right, let's just hypothetically, let's say it's 100 meters. All right, definitely if you're standing 100 meters away from it, okay, that the impact there is less. If you move closer, the closer you move, the more impact you get. So it has nothing. It has nothing to do with it. It is where you are in relative to it. But what we are saying is that the characteristics of the
wave. So I'm saying that when the transmit power is increased, even though you may be at 100 meters, it will look like you are at 50 meters. That's the argument I'm trying to make.
Yeah.
So that is the point I'm trying to debunk. It doesn't work like that. The wave itself.
It doesn't work like that.
No, the wave itself has a defined threshold. It can't go beyond those thresholds. So whether you boost it or do it, it can't go beyond that. If you want it to traverse beyond that, you need another node, just like a wireless access point.
That's right. I want to add one more thing, Sam. I want to add one.
Whereby you do like a cascade.
Exactly. Yeah. So if you are doing networking, all right, for those that have done networking, after 100 meters, attenuation sets in. So you need a boost after 100 meters to take. Exactly. So that's the point. So if that's what I'm saying, that hypothetically, if you say 5G, the wavelength is 100 meters. After 100 meters, there's nothing you can do. If you want to take the signal beyond, you put another 5G node at that 100-meter mark or before the 100-meter mark, so that they can take it to another 100 meters. Does that make sense?
Yeah.
It makes sense. More thing. David, what about from your view, from your angle of radio?
Okay, I want to add something, Kevin.
Yes.
In developing the standard for 5G, the 3GPP team and ITU, they put in some measures, because there will be a lot of a lot of nodes that will be required to be able to transmit this and cover a particular area. For example, they say a 5G network can actually connect 1 million devices within a square kilometer. So that is huge, right?
Yeah.
But the thing is, if you don't put standards on how much transmit power that you're supposed to, the devices are designed to, because the devices that they have maximum power they can transmit, like the way you have for 2G and 3G. You are a network, a telecom engineer. You know, when you get to the side, you can't increase the power beyond a particular threshold of dB, right? Right, because the devices have been designed with that standard to ensure that nobody will just go and amplify it and open it up to unreasonable level. So those are standards that have been set already, and all original equipment manufacturers are designing and manufacturing their equipment within those standards. Am I making sense? I'm just trying to add, in addition to the natural propagation level of frequency, there are also some standard guidelines that are being used to deploy this.
Thank you, David.
Yeah.
So
Okay.
I think that should clarify a lot of the 5G.
Unfortunately, we have moved into this space where people are going to be asking a lot of questions. I have here Joel. Joel, please can you unmute and ask your question or contribution?
Yeah, hello.
Hi.
Yeah, this is Kate.
Oh, okay.
Yeah, so
Kate.
My question is on a particular use case. So considering the part of the world that we are in terms of animal farming, the infrastructure that they put in place in the farm normally is not enclosed. So if we take like cattle, for instance, they take them out to graze, sometimes for days, weeks before they come back. So I want to know what kind of IoT infrastructure can be used to track these kind of animals in the first place. And say if one animal get lost, how will they track it? If it goes outside the main, where the head is, how will that also be tracked? So that's my question.
All right. I was just going to go into those ones. So I guess let me just get there, like in the next couple of bullet points, and then I'll explain that. Now, so
sure.
these things that I'm talking about right now, like I mentioned Bluetooth, like now we've mentioned Bluetooth, we mentioned light fidelity, near field, radio frequency. We also have low powered wide area, or what we call LoRa. All right. And then we're talking like Wi-Fi. Now, these ones are what we call short range wireless. All right. Now, with a medium range, things like LTE or long-term evolution, or the LoRa and other, those would be like in the mid range. However, for what you are asking, those who fall in the category of what we call the long range. All right. Now, an example of a long range would be, we can say things like VSAT, all right, satellite, so very small picture terminal. So satellite is almost like global, is that not it? So if you have IoT devices that are configured on, using the satellite communication, then you can track the heads irrespective of where they are. LoRa is also another technology that you use that is like very long range, but allows you to transmit in a low data rate, all right? So they can actually implement LoRa networks across a large area, and that should also cover it. But then you have things like VSAT that is available for you to use. I don't know if that answers your question. So technically, in such scenarios, you're looking at satellite connectivity. I hope that answers your question. So these are the network and connectivity infrastructure that support IoT. All right, that supports IoT to the core. So any of this can be used. And the question you ask is very valid. When you are doing an IoT deployment, these are some of the questions you ask. You're going to ask, what is the range? What are the devices? What the use cases would help you determine which of the protocols or networking communications to use. Whether it's just a bunch of sensors or devices around your neighborhood. Would it mean that you can just do LoRa or you can do Wi-Fi, And another thing as well is that, I don't know if you people are aware of it, you can actually transmit data through power lines. And I think MTN is doing that with ECG in some places. So instead of them laying their own copper cables, they're actually passing data through existing electricity lines. And that is what we call the power line communication. This is done. I don't know if you are aware of if you're aware of access points that are running through your regular home plugs. There are devices that when you buy and you connect, they connect to your internet. So you plug it in a power switch socket on your wall, it connects to your access point, and then all the plugs in your house are now internet capable. All you need to do is plug another device in another plug, and that room already has wireless internet. So that will be for the power line communication. So these are varying network connectivities that you can use.
But why are we not deploying this? Because we at least we have about 80% of Ghana now connected to the grid. So why are we not?
So that's what I mentioned. I know MTN is doing this with ECG in some areas. They are leveraging, they are passing data through the.
What I know they are doing is that they are using their poles to connect their fiber optics. For example, the fiber optics they brought to my house, they use the ECG pole to bring the fiber optics.
Yeah, but now they're actually using the ECG cables.
Yeah. Because I think that should be easier for us to connect everybody, you know.
It is, but you know, it comes with its own other infrastructure requirement. Like for instance, they will need to reconfigure the whole, you know, power lines in segregating the data, and you know, that's why, that's why they are. So in new communities, like new gated communities where they are now implementing, I know in community 24. Vodafone or MTN is doing something in there where the power lines that are coming to your house are the same for internet. So they're able to do this in newer development because then they're able to configure this properly.
Right.
So now let's talk about the data protocols. All right, we've talked about communication protocols. Let's talk about the data protocols. So the data protocols are the infrastructure of protocols that allow for the actual transmission of data and all these things, right? The very common one is the MQTT, what we call Message Queuing Telemetry Transport Protocol. All right, this allows for what we call the publish and subscribe messaging model, where a device sends a message and another device subscribes to receiving messages from that particular device. Now, it is extremely lightweight and it's useful for connections in remote locations, okay, where you just need a small code footprint or where, you know, network bandwidth is quite expensive. So you can use MQTT as a data protocol. All right. Then we can talk about MQTT for sensor networks. This is kind of like a lightweight version of MQTT, like a stripped version of it to make it even lighter for devices that cannot, you know, take a higher, that don't have higher specs, right? Then we can talk about the co-op, or we call the constrained application protocol. Now, it works at application layer, all right, and it's intended for use in resource constrained internet devices. So you have internet devices that do not have a lot of resources to handle communication. It would work on this particular data protocol. Then we can have the simple text oriented message protocol. This is just basically sending just simple text messages across, all right. Then we can also talk about what we call the extensible messaging and presence protocol. All right, this is an open technology for real-time communication. Now, this powers a wide range of applications. All right, it also includes things like if you want your IoT devices to be doing instant messaging, multi-party chat, voice, video, this would be your data protocol. However, it's quite huge. So there's a stripped version of it called SMPP IoT. That is a stripped down version of it to allow for devices to communicate much efficiently. Then we can also talk about WebSocket. All right. Now, WebSocket is basically one of the standards that was developed as part of HTML5, and this allows for you to connect over, you know, streams and allow for client-server communication and, you know, much bi-directional, easy communication. Then another popular one is what we call the advanced message queuing protocol. All right, this is also an open standard application layer protocol. It also allows for message oriented middlewares. Now this allows you to do queuing, routing, and point to point and publish and subscribe. So most IoT deployments I have done is between AMQP and an MQTT, these two, because these are much reliable ones. Then we can talk about another common one, which is the data distribution services for real-time systems, which is just it's just a middleware, an open middleware that allows for direct addressing of publish, subscribe communication. All right, also for real time. It's also one of the common and fast growing ones. Then we can talk about the lightweight local automation protocol. All right, this is a simple short message that is sent between two objects or two IoT nodes. All right, normally it would be in a text format, but it's not like TCP or Bluetooth or Zigbee. This one is very, very, very low, like very low rates, and then it can it can run on anything. Now the good thing about the lightweight local automation protocol is that it was built to be very resilient, so it can run on anything yesterday, it can run on anything now, and it will run on anything in the future. That is how and I'm currently exploring this in some deployments we're working on. Then we can talk about the lightweight machine to machine protocol. All right, now this allows for systems to communicate. It's part of the Open Mobile Alliance and includes things like the how do you call it? Things like the constrained application protocol is part of it. It's part of the lightweight machine-to-machine protocol. All right. Now, then we can talk about conventional REST. All right, which is the representational stateful transfer. So if you've been doing some web HTTP and all that, that is also usable within IoT data protocols. Then we can also talk about HTTP2, which also allows for that. Now, let's take a look at some of the concerns, of IoT. Now, the first concern that has been
before
raised.
we go on with the concern, there are two hands up.
Okay.
Nyonyo wants to ask a question, and also Cyril. So Nyonyo, please go ahead.
Okay, so I have two questions or concerns. Now, when you made reference to the PLC, that's power line
communication.
Yeah, power line communication. I found it quite ironic, even though yes, it's in use, because when you're laying Ethernet cables, it's advised that you can't channel the same Ethernet cables through the same pipe as the power cables
because of EMF.
Yeah. So that's one, irony I find in this whole thing. And then secondly, when you take our new ECG meters, it's possible to sit back at home and then buy your credit, and then that gets loaded on the meter remotely.
Yeah.
What protocol, what mode of communication makes that possible?
Okay, so to the first question, yes, initially when protocols were growing, right? There is, and this is a physics phenomenon. When you have when you have wires or cables that have current flowing through them, they generate EMF. They generate an electromagnetic field. All right. Now that's why they say that when you twist them, the fields negate. So that's why we have twisted pair cables and all that. So if you look at most of the Cat5, Cat6 cables, if you look into it, they are quite twisted, right? Just to negate the effect of EMF. All right. So those were, like we said, they were valid theories, years ago. But now with the advent of Cat6 and other IP6 and all that, they have some interventions and mechanisms even in the cables that avoid that. So now if you even look at most of the Cat6, they are shielded Cat6 cables. I don't know for those of you networking have seen it. I dropped my networking thousands and thousands of years ago, but I still follow up with that. So there are shields in it, and they are twisted to negate the EMF effect. Now, another thing they also do is that current and internet are all it's converted in the form of analog signals or analog current. All right, that is translated at the edge. Is that okay? That is the main reason why it is possible to pass both, data and power through the same line. The only thing is that when it gets to the termination point, there are devices that separate the current from the data. Does that make sense? So they coexist. They coexist peacefully. It's just like, think about it. They say fiber optics. Now, those of you who were thinking that Li-Fi was overrated, it is the same phenomenon in fiber optics. Now, the fiber optic, the fiber cable is that tiny fragment of light running through like a glass. It's like how do shavings of glass.
Yes.
All right, and light
Yes.
is being passed through these shavings of glass. So think about it. So how is data running through the light? It's the same thing. It's the same phenomenon as Wi-Fi. All right. So the data is passed through light, and this light is traveling through a cable that has series of shavings of glass, and the light is traveling through them. All right. So data can be transferred through light. Data can be transferred through sound. For those of you that are not aware, data can also be transferred through sound.
Yeah.
If you follow my IoT channel, I think I did something on that where we use sound to configure an IoT device. We play a particular music, and that sends the username and password to an IoT device because that data has been encoded in the sound. All right. So data can be transferred through current, through light, through sound. And who knows, there are a lot of things that are coming. Just the same way you are receiving your telephone calls. It's traveling through waves, all right, through the air. So there are a lot of ways that data can travel. So that's the irony part. Now, in terms of how your smart meters talk, most of your smart meters are using the Zigbee protocol that I mentioned. They are using like machine-to-machine protocol. And if you look closely, all right, most of the areas that have the smart meters, ECG has some form of access point on one of their poles around. They've done something called the mesh network. So your smart meter is actually communicating with that gateway that is on one of the ECG poles. They don't look very conspicuous, just like some white box. You think that is one of those regular boxes, but that is the gateway in the mesh network. So all your smart meters are communicating to that gateway. That gateway is what has the internet access that goes to ECG. Does that make sense? So your meter is part of the mesh. It's a node in the mesh, and it's talking.
Even there's a small antenna. There's a small antenna, attached to it. So it takes the signal, and that is the communication part.
So that's how your smart meter communicates with ECG or gets to ECG. That's how it works.
Okay, there's another hand up, Cyril.
Okay, thank you very much. Please, I would like to know with the types of the infrastructure you laid earlier, I want to know how cost effective they are, so that when you are trying to use this type of infrastructure, you know that, okay, with this, I need to put this type of maybe money or fund into this, so that I'll be able to work within my range.
So to answer that, I mentioned that your IoT deployment will determine which technologies or infrastructure you go for. All right, it depends on what you're trying to do. Like for instance, the question about the cattle heads. Okay, someone wants to know, I have 500 cattle heads, and we can go for weeks. So which means within a week we could travel like kilometers, lots and lots of kilometers. Okay, in that case, you ask yourself, okay, if we still want to be tracking our cattle over 100 kilometers, right? What will be the best networking protocol or networking infrastructure to use? Would it be safe to say that we use VSAT? Would it be safe to use that, okay, we deploy some LoRa network? So the application you are trying to deploy will determine. Now, let's take a look at those cattle, these Fulani herdsmen that come from all the way from Mali or wherever they come from with their cattle. What technology, what networking infrastructure do you think they will use? For them, technically, it's VSAT. Because you can't have any easy networking infrastructure that will be running from Mali all the way into Ghana. Does that make sense? So for that implementation, they would go for VSAT, and therefore, because that's the only viable networking infrastructure they can use to track their heads globally. So they know that in terms of cost, they can't run away from it by use VSAT. So your IoT implementation will determine what infrastructure to use. And every infrastructure has its own cost. If you decide to use 5G, it's on to you. If, for instance, the government of Ghana or city of Accra decides to do smart parking, they have a lot of options, whether they want to go with a Wi-Fi mesh or a LoRa mesh network, or they want to do 5G, it's up to them. But whichever infrastructure you pick comes with its own cost, because 5G equipment are not cheap. All right,
Yeah.
it's the
Yeah.
same thing. So depending on the infrastructure you pick, there's a cost associated with the hardware for that infrastructure. So that is how you price it.
Right. Okay, let's take the next question from Luis.
Yes, just a follow-up to Cyril's question. Does it mean, in essence, it is the IoT infrastructure or your use case that determines the kind of network connectivity or the network communication you're going to, and not your money at hand?
Yes. So this is it. It is your IoT use case that determines your IoT infrastructure, and it's the infrastructure that determines the cost. Does that make sense?
Okay. Okay.
So
Okay.
it is all related to money. So if you don't have money, right? If you don't have,
Yes.
if your budget doesn't fall within the range of a particular IoT deployment, you are forced to improvise or use maybe a cheaper solution which might not give you effective or required output.
That's right.
You get the point.
Okay.
Like for instance,
Yeah.
let's still use the cattle heads for example. If the owner of the cattle, someone has 1,000 cattle heads, and these are roaming from Niger to Ghana to wherever, all right, we know
Okay.
that for him to track these cattle effectively, he will need to have what? He will need to have VSAT across globe, all right.
That's right.
If he
Okay.
doesn't want to use VSAT, which is the most viable one, because he say, Charlie, my money is not up to get VSAT satellite connectivity, he might resort to use cellular. All right. But what
Okay.
is the challenge for cellular? Now, it means that any country he goes to, he first of all has to start having some alliance, or he has to buy something they call international SIMs. It's very popular in IoT circles. These are SIM cards that the companies have already negotiated with different countries across the world. So if you have an IoT device that is working on cellular or 3G or LTE, if you get into that country, it will work, because just like roaming, your device will start
Okay.
using a network operator within that country, but then there's
In
a
that
cost
country.
to it. You get the point. So
Right.
that is how it works. Your IoT use case will determine your IoT infrastructure, and your IoT
Infrastructure.
infrastructure will determine
Okay.
your cost.
Cost. Okay. Okay. Thank you.
All right, so let's move on. So now let's
You
talk.
want to move on by so many questions. Huh?
Okay, then how about David? David,
Yeah.
how about I run through what we have and then we ask the question. So let them.
That's right. I think
Let them write. Yeah, that'll make it exactly.
Otherwise, we'll not be able to finish.
Yeah.
Also, so let's move on. Let's move on.
Okay, so first of all, let's talk about the very first concern is platform fragmentation. All right, so this is one of the fundamental problems IoT suffers from. Okay, now there's a lack of interoperability between common technical standards. All right, now this is where there are a variety of IoT devices. Now, speaking variety of IoT protocols, all right, there's no standardization to say that when you are doing your deployment, use let's say LoRa and do MQTT. Is that okay? There isn't any fixed standard to do that. Just unlike the way the web says that if you want to create a web application, it has to be HTML compliant so the browsers can read it. For IoT, there's a lot of standards that no one is saying all IoT implementation should use MQTT or AMQP. All right, nothing like that. So there's this whole fragmentation that makes it very difficult. So I can have my deployment on LoRa. David can have his deployment, let's say, running on Wi-Fi. All right. It becomes difficult for our two IoT systems to communicate or to interoperate. That is one of the problems. Now, the next thing is privacy, autonomy, and control, which someone just asked. It's a concern. Yes. The Internet of Things offers immense potential for empowering citizens and making government transparent. All right. And even broadening like information access. However, privacy threats are enormous. So asking, it's a potential for social control and political manipulation. As for that one, no two ways about it. The concerns are that, privacy may lead to, considering the possibility of big data infrastructure. Okay. Now, what we know is that Internet of Things generates huge big data. All right. Now, the problem is that once this data is generated, storage is another thing, which will be the next thing I'll talk about. All right. There's a challenge in how we use this data. There's a fear that with all this data collected, if there's no policy to regulate the way the data is used, there might be abuse, or there might be, you know, kind of like some cyber deficiency, you know, to IoT. Then the next concern people talk about is data storage. Like I mentioned, think about it. Your sensor is collecting your pulse every second. All right. Your fridge or your air conditioning is sending data every minute, every, you know. So there's a lot of data generated. The problem now becomes, okay, where do we store this data? Even if you are storing it, at some point it will grow into the petabytes of data. And as you know, cloud storage is becoming, you know, even though we're expecting it to come down, it's quite expensive. So the more data that is generated, storage is becoming very difficult to handle. However, these concerns can be addressed in the architecture of IoT solutions. A typical example would be, if there is time, I'll show you a demo where I have a temperature and humidity sensor right now, which is reading the temperature in my room. And this is sent to Azure IoT Hubs. And based on the conditions of my room, it's able to trigger a fan in my room to turn on or off. Now, I don't let my temperature and humidity sensor send data every second. A simple strategy I've adopted is that it reads the last temperature value is sent to the cloud, it stores it. If there's a change in temperature, all right, and it is the same as the very last one, there's no need sending it to the cloud. However, if there's a difference in that temperature, you can send it. So with architecture or tips and tricks like this, you can minimize the amount of data your system would generate. All right, cool. Then we can talk about security, which is the last thing, you know, not the last, but one thing that people worry about. Now, security is one of the biggest concern in adoption of Internet of Things. All right, with the concerns of people are talking about rapid application development happening without appropriate consideration, with no security implemented in it. For instance, people have smart cameras in their homes and they forget to change the default password, and people go online and get the password, they hack, and they put it on unsecured Wi-Fi connections and all that. Now, these are all concerns, but again, these are addressable with technologies, addressable with the architecture and proper best practices. Let me give you an analogy. People say that, oh, cloud is not secured or IoT is not secured. Let's use an example of this popular techish doors. These techish security doors are supposed to be one of the safest doors. True or false? Most of us have heard. Now, I can go and buy a bulletproof, whatever, bomb-proof door, all right, and fix it and lock it. However, if after locking it, I put the key in a flower pot close to the door, and someone comes, a thief comes, sees the key there, picks it and opens the door, would you say the door is not good? No. It is your negligence. It is the part you didn't play. It is that bad practice of you left the key in the flower pot for the person to see. That is what is happening. So if you follow best practices, this is very, very safe. All right. Now, the final thing people are concerned about when it comes to IoT is safety. All right. People are worried that with the fact that IoT becomes autonomous and is collecting sensor data from here, sending it here, running this and all that, there's a fear that what if it reads the wrong sensor value? Let's say, for instance, my sensor reads the temperature and humidity sensor in my room is 40, and it starts saying that my room is 120 degrees Celsius, which means it's crazily hot, and then automatically it tells my air conditioner to go below freezing point. That will kill me, right? So those are some of the safety concerns. But again, these are all addressable, you know, with best practices. Now, let's take a look at the adoption barriers. Like, these are things that have prevented people or businesses or organizations from implementing IoT. We mentioned the lack of the fragmentation. So here, lack of interoperability and unclear value proposition. So first of all, people are not, most IoT people are not able to determine how would this bring value to my business? At what point, you know, do I implement IoT? And can it operate with my existing infrastructure? That is one of the concerns, all right? Then there's the ever privacy and security concerns, which we've just addressed. They have issues of, you know, how secure it is, how am I, you know, privacy and all that. We've talked about that in the previous one. Then there is no traditional governance structure for IoT. Like I mentioned, there's no traditional standard to say all IoT deployment should follow this process or this process. There's nothing like that. So it's making people reluctant into deploying IoT solutions. And then there is no business planning and model for it. It's the same thing. Nothing has come up yet. Even though the Zigbee Alliance, the Z-Wave Alliance, and other smaller groups are trying to formalize it to make it much more standardized. And we are going to see this happening in the years coming. There's going to be more standards. There's going to be more clarification. There's going to be more education to make people understand and feel comfortable in deploying IoT solutions. Today, a lot of companies have deployed IoT solutions. It's working for them. A lot of people have started, but they are stuck because of these challenges. And we are hoping that with such education and and sensitization, we will move past that level. Now, these are just like an overview of how do you call it, the problems concerning adoption. We've talked about security is very high, the IT and IoT integration very high, the unclear return on investment. People don't know, well, if I implement this, how is it going to give me a return on investment? People still don't have it. Then there's also a challenge of technical expertise. There is only little or few people in the area of IoT that are specialized. That's another problem. So if you're embarking on it and you don't have the resource, it becomes a problem. Then we can talk about interoperability. We can talk about data portability. How can I move data from one IoT implementation to another? That can be fixed by proper architecture. There's also the vendor risk. Because IoT is ever growing, there's a fear that I might go with this vendor and tomorrow the vendor is no longer, or he's been bought, or he's been moved into something else. And then also the same for transition. Then there's regulation, there's network constraints, and then vendor locking. Vendor locking is a common thing, but now I realize that is going down because most of the vendors now are making their IoT deployment or devices open. So this is where we have all these concerns and all that. So that's the IoT overview and its infrastructure. Now, because this session was not more into getting started with IoT, I would have gone further to talk about IoT devices and all that, but I don't know. Let's take the questions. If there is time, I can show you the demo, because even with the demo, I need to set up my environment so you can see the demo. So I think let's go ahead and take the Q&A. And then whilst we're doing that, I will see if I can try to set up the demo and then I'll show you. So David, if that works for you.
Yes, please. Yes, please.
Awesome. All right, so so now we can ask the questions, and I think yeah, so we can have the questions coming whilst I try to set up to see if I can show you guys this demo. It looks like we have some time.
Yes, we have some time. Please ask your question now. I have Joel. Joel, please ask your question. Joel, please unmute and ask your question, please.
Hello.
Hi.
Can you hear me?
Yeah.
Okay. Well, sorry, mine was not more like a question. It was a little bit of a contribution that I wanted to add to the whole thing. I basically want everybody to understand that IoT has always been around, and if you are coming from a network perspective, you will understand that there are specific devices that you can put at the endpoints of networks, and then certain commands can't be sent through these devices or gateways to wherever or whatever you want it to do. If you are experienced with things like PLCs that are used for plant automation and all that, you realize that some of them have interfaces that you can send command line commands to, and then they can either trigger a valve to open or close. This has been around many years back, except that now IoT has come and it allows us to formalize the way that these communication protocols and gadgets are linked together. I believe it's a bit of an advanced version of networking. And so anybody that has understanding of networking should rather delve into the use of some of these devices that are internet enabled to trigger commands, and basically an IoT environment would be in use. And for the question about how animals that are traveling over a long distance can be controlled, I'd like to find out from you if there is a possibility that a device could be given to the herdsman who would be with the cattle. And that device would have kind of Wi-Fi or Bluetooth connectivity to the various sensors on each of the animals. Once this device is GSM enabled, I believe communication can be derived from the animals through that GSM device. I don't know whether that's clear.
Yes, it is clear. Actually, it is doable. That's what we call the gateway system. So all the devices on the cattle will be nodes that are communicating with the gateway. So the drawback to, like I'm saying, it is like, again, it's the infrastructure and the use case you want that will determine. So in the case where the person says, me, I don't have money for VSAT, okay? I don't have money to be giving you VSAT, so I can track my cattle all across the globe, all right? So a gateway device, like you're saying, can be given to the herdsman. That has, like I mentioned, either you buy the global SIM, or it can take a SIM card, or it's Wi-Fi enabled. All right. So today, it's also a gateway. So as the herds is always with the cattle, all the cattle sensor data is going to go to the gateway, which is called the edge. That data is always going to be stored to the edge, only accessible by the herdsman. However, if he gets into another country, he might just go and, let's say, buy a new SIM card, buy data on it, connect the SIM card to that gateway, and now the cattle owner, wherever he is, can, for that particular period, can now access and track the cattle based on where the person is. So if the person moves to another country, it's probably a matter of buying a SIM from that country, buying data, putting it. So yes, there are implementations like that. I don't know if that makes sense.
Please, I have a question.
Sure.
Yeah, my question is, please, can I go on?
Yes. Feel free, please.
Yeah. Do we have IoT surveillance system for CCTV? Like people use CCTV camera for monitoring of things and other things in the office and stuff. So can we, is there any relationship between the IoT and the CCTV camera, something like that?
Yes, there is. There are actually deployments that do that. For example, with this COVID, there are actually CCTVs that have embedded what they call thermal imaging. So what happens is that you are seeing it just like a normal camera, but it has AI in it that is able to detect the humans in the video. And then also what it does is it also allows you to how do you call it? It allows the camera to take your temperature reading, all right, at the same time. So that particular camera, though it's a CCTV equipped with AI running on the network, can tell out of the 10 people, this person has a higher temperature, which can be synonymous to COVID or flu or whatever that is.
Right.
Okay.
Somebody also want to ask a question. I can see another hands up. Cyril, I think Joel has asked his question already. Cyril.
Okay, sir, please. I want to know if still using the animals and the farming as an example, what measures are put in place to help people who need long-range infrastructure but they have low funds? So, like a farmer who has maybe huge cattle or something, and the person needs an infrastructure that covers a huge range. How or which measures are in place to help that?
So I think we just mentioned that's one. Now, if you are looking for how do you call it, a long range network, your deployment to determine what to go for. If you're already within a network zone, I don't think you need to put in any infrastructure. But if you are not in a network zone, your best bet will be to deploy what we call a mesh network, where you are creating your own local network to collect the data you want, send to a gateway, and then it's only the gateway that has access to internet. Now, let's get this right. I mean, the fact that we are saying IoT is connected things, it doesn't always have to be on the internet. Once it's on a particular network, the internet is just a network of networks. All right. So so far as those entities or nodes or objects are on a network, not necessarily on the internet, it can be termed IoT. So don't have the notion that IoT means everything has to be on the internet. That's not always the case.
Right. This answers a question that has been posted on the platform. Somebody asked, Fifi said, "Thank you, Samuel, for this education on IoT. If you have a localized deployment of interconnected devices that don't connect to the cloud, example, using LoRa, will it pass for IoT solution because it doesn't connect to the internet?"
Oh yeah, it passes.
In the Coca-Cola example, implementation is possible without connecting to the internet.
Yeah, exactly. Yeah. So yeah, that's also IoT. It doesn't always have to be on the internet.
Right. Do we have any more questions? So the presentation is done. Please, if you have questions, please ask. We still have some few minutes to go.
David, I just wanted to ask. I don't know.
Yeah. Who is Herman? Hello?
Yeah. Can we say, can it be used when you have something like a closed user group? Can that as well be termed like as an IoT?
A closed user group, but is it connecting objects?
Yeah, that is connecting. Because let's say a closed user group that is connecting objects. Because as it is now, for me, I believe that one has become so, it's expensive now, and we, in the era where we find ourselves doing a lot of SD1, that is wide area, software-defined wide area network. Closed user group can be used to be able to achieve some of these things, and I want to confirm from whether from the presenter whether it's possible we can be able to use this to achieve what we want to do, like a network like that. Yeah,
I would say that yes, that is doable. Okay. It is very, very, very doable. It is very doable because remember, IoT, I define it as connectivity of objects. So it can actually be. Let me actually. Do you know that most? I don't know if our Air Force has it, but do you know that in the US, right, the Air Force suit, all right, that the pilots wear, right, are all like smart suits. So it's able to report the vitals of the pilot whilst he's flying the jet to, through the various satellite connectivity that the Air Force has, and then report it to base. So at every point in time, they know the vitals of the pilot in the plane. So IoT doesn't, that's why I said I defined it as object, not just devices. All right. It could be your cat. It could be something you put on your cat. And when you put that on your cat has become an IoT, device or object. All right. Do you get it? It could be my fan. Yeah. It could be my fan. Okay. The regular ceiling fan I have in my house. The fact that now I have connected that ceiling fan to a relay, and I've connected that relay to an Arduino or Raspberry Pi. And then now I can send command to the Raspberry Pi to turn on the relay that turns on the ordinary fan. That fan has become an IoT object or device. Does that make sense?
Yes, it does. It does. Because what we know for a fact is that most of those military grades, they are using air gaps, and just that same goes through with like a closed user group that we have. So for me, I understand where you're coming from.
Yeah, so that's also possible. I hope that answered your question.
Okay, there's
yes,
another.
you have.
Hello, Mr. Samuel.
Hi.
Yeah, please, looking at the cost involved in setting up an IoT and the other stuffs involved, the privacy and the storage and all of that, does it really make life easier? Does IoT devices, IoT implementation, does it make life easier? If it does, how? Because it involves a lot of cost. And I don't know. I just felt, why are we pursuing it? Why? Is it implementable in this part of the world?
So, oh yeah, I have a lot of IoT stuff going on in my home right now, which I'll demo a small setup to show you how it works.
But how many people can afford it as you? You can afford it. A lot of people cannot afford it. So what do we do?
David, let me answer that. David, let me answer that. So listen, it is not as expensive as you people think, right? Are you not already using a phone? Are you not already using a phone?
I am.
There's some level of IoT going on there. Do you know that your phone has sensors? Your phone has GPS, right? That allows you to know where you are at every point in time. Do you agree with me?
Yes,
do you agree with me on that? Now, there is a free service online. Exactly. There's a free service online called IFFT. If this, then that. All right. That allows you to say that anytime I receive an email, all right, or anytime I get close to home, do something. So IoT is not necessarily, yes, it can be expensive depending on what you want to do. But IoT in its own, it's not technically limited to enterprise or large scale deployment. Is that okay? And the demo I'm going to show you is simple. I just have a Raspberry Pi. It can be an Arduino Uno, and then a relay, and that's it. Nothing. Like I'm saying, you don't have to buy new infrastructure to use IoT. I mentioned that I can have a ceiling fan, an old ceiling fan. All I need is a relay to turn it on and off. That's it. I can make that ceiling fan smart. So the implementation of IoT is not like, it doesn't always have to be, the, how do you call it, the thousands of dollars or anything. No.
Okay. Thank you.
Okay, great. Any more questions, please? Or you guys enjoyed the lecture and you want us to come to a close? Somebody send something.
If there's time, I can just show a very, very quick demo. Very quick.
Yeah, we still have 20 minutes to go.
Okay, let me do that, and then maybe we can maybe that'll
Somebody's asking a question. I don't know
what
somebody said. What's the difference between IoT and Internet of Humans?
So that is why I said IoT is, you can say, we're actually even trying to find a good term for that. So it could be Internet of Humans, Internet of Animals. It all falls under the IoT, that category.
Right.
Okay, so I'm trying to, pardon me, I'm trying to set up my system so that I can, I can stream this and share that, so you can see this. So pardon me.
Right.
Okay. Okay, so let's do this. I am told I can full screen project. Okay, so I'm going to try something right now. So bear with me and let me know if you can see it. It's because of what I'm trying to do, just to make sure you can see my demo.
We are not able to see it.
Okay, let me know if you can see my screen.
It's coming. It's coming. You can see now.
Okay, so you're able to see me just like I would have been running my show, right?
Right.
Okay, let me know if you can see my workbench.
Yes.
You should see some relays and stuff going on there. Can you see that?
Right. Yeah, we can see that.
Okay, awesome, cool. So I'm just going to take this time to explain what you're seeing here. This is an IoT setup, all right? This here is a Raspberry Pi. Okay, this is a Raspberry Pi. This Raspberry Pi is connected to my home Wi-Fi. All right. It's connected to my home Wi-Fi. I think someone's microphone is on. If you can mute it.
I've turned it off now. I've turned it off.
Okay. So now, okay. So this Raspberry Pi here is running. It's connected to my home Wi-Fi. Okay. And I'm running a Node application on it, and the Node application is what is making all this possible. I could have run Python or anything. Now here, what you see here is a temperature and humidity sensor. So this is reading the temperature and humidity in my room where I'm having this presentation right now. Now this here is a relay. This is an 8-channel relay. I'm not using all the 8. It means that I can use this relay to control 8 different things. Currently, I'm just using it to control this fan. Now, do you see that this fan is not a smart fan? This is one of the fans you find in your computers or servers or cooling system, right? Do we agree? This here, this is not a smart fan.
Yes,
it's
yes,
not. It's just an ordinary fan, okay? But I've connected it to the relay because I want to make it smart. I want to make it IoT enabled. All right. I have an LED here, but you might not see it well. So to show you what's happening, I have an app that allows me to control this anywhere in the world, but I'm going to show you through the code. So you see that it's very simple. I'm not showing the app because the app is built on Microsoft Power Apps. I don't want to be platform. I want to be platform agnostic. I don't want to go with any particular platform because you can do this with any platform. All right. So I'm going to flip here and try to show you how this is working. You should see 4 screens right now. Can you see that?
Yes, you can see 4 screens.
Yeah,
okay,
it's showing.
Good. So now what I'm going to do is now let me see if, let me know if you can see my code. Can you see the code on the top left?
Yes, we can see.
This is a normal for those who do web development. All right, this is normal. This is just like a normal Node application. All right, normal Node application. Nothing fancy, nothing crazy. Now, the only thing I want you to pay attention to is these 2 methods here. And sorry for those that are not programming, but it's just a simple thing. Now, this is just a function that is running on this Raspberry Pi. These 2, toggle LED and toggle fan. This is a function on the Raspberry Pi that anytime I call it remotely via an app or by my smartwatch or by voice, this will turn this fan that you are seeing on or off. All right, so let's try it. I'm not going to use an app. I'm just going to do this right here. So let's try this. So I'm going to send this command. Now, how do I send the command? I'm going to send the command right here. Let me bring this out. Okay. Oh. So you can see that I'm sending the command. So let's open this up. So this here is something we call a digital twin. So this digital twin is a digital representation of my Raspberry Pi in the cloud. So I can send commands to it anywhere in the world and it will control this fan here in my house. So look at this. I'm going to invoke that method. It's called what? Turn on the, can you see it? It's called toggle what? LED. So now I'm sending an on command and keep looking at the top right where the fan and the relays are. If I send an on and I hit enter, do you see the fan is running?
Yeah.
Do you see that? Yeah, it's running. All right. So I could have controlled this from an app, from my phone, from sending a text message, from talking to it. If I want to turn it off, it's the same thing. I right click here and I go to invoke device direct method, which is a method on the device. I paste in the toggle toggle fan, and this time I send what? An off command, and I hit enter. And then if you look there, you should see that it's gone off. Can you see that?
Yeah, it's going on.
That's simple. This is IoT.
Yeah,
right?
it's working.
And to further show you how this is going, let me show you now let me go here and show you the code base, and let me show you how the data is being sent. Quite simple. And I told you that you have to be smart about the way you're sending the data. So if you look closely, I'm not sending the data when the temperature value doesn't change. It's still 25. Nothing is sent. You see it? And look, anytime I send a command to it, it reports the command, it reports the state of my fan and the light to the cloud. So I can know at every point in time whether my light is on, my fan is on or off. All right. And this is it. You see that it is not sending anything to the cloud, because the last temperature value it sent was 25, and still the temperature value is still 25. So there's no need to send it. So you're not generating extra data. Does that make sense? So these are just some small mechanisms to prove to you that it only sends the data when the temperature drops. I'm going to use, let me flip back here. So this is like a heat gun. It generates heat. So I am going to put this, as you can see, on the temperature and humidity sensor there. And when it detects the change in the temperature, look to the top left. You see that it will start saying it's sending data. Now, do you see it? It's sending data to what? IoT hub.
Yeah.
Because now the temperature is 60. Let me stop. Oh, I think I just bent my temperature sensor. But no problem. I have another one. So, no, I mean, no problem. I have lots of them. Now, so you see that it's because the temperature went high, it knows that, okay, there's a difference between the last temperature I sent and this new temperature. Do you see that? So now it's reporting it.
Yeah.
All right. So now I say now it's still 60. So it's not sent it again. So it's only going to send unless there's a change, because the last data I sent was 60. The temperature is still 60. All right. I don't need to change anything. Does that make sense?
Yeah.
So these are some of the strategies you can use. And this is a simple node application. And in terms of security, this application is very secure because it's running to the Azure cloud using some secure tokens, all right, which this application only has. And I'm only giving access to certain pins on the Raspberry Pi to the application. So even if you hack the application, you can't access the other, input output pins on this Raspberry Pi. Does that make sense?
Yes. So there's a question here.
Sure.
Somebody wants to know what are some of the jobs that will be available for most people under the IoT?
Oh, I can say there's a lot. Because right from the networking infrastructure, as you can see, definitely there is a need for it. And you can see I just wrote, okay, let me go back. Look, the temperature is dropping to 58, so it's sending. That's just by the way. So it dropped 58, 57, it sends it. So now the temperature in my room is dropping. So as it's changing, now it's going to send it. Now, back to the jobs. Application developers, this was created in Node. So if you know how to build a Node application, there's a job for you. User interface developers, this is not, I don't need all this plenty gibberish in code. All right. I would want a nice mobile application that I can use to control my device wherever I am in the world. So people who know how to build mobile development. So there's a whole lot. There's a whole lot of opportunities.
Great.
I don't know if that explains it.
Yeah. So now, how do people start? Let's say I'm just coming in now. Okay, it's a fantastic concept. How do I start? Where do I start from? So,
like I mentioned, I was tempted to put getting started in this particular session, but like we all agreed to. This is more of like an overview and infrastructure.
That's right.
We can have a complete session on getting started. Then I can talk to you about where is that? I think I need to flip back to this. Then I can talk to you about things like the Azure Sphere. I can talk to you about things like where is that? I can talk to you about things about like the Arduino Uno. We can talk about ESP8266. We can talk about getting started. Basically, once you understand this core concept, getting started would be as simple as getting maybe an Arduino, an entry-level IoT microcontroller, see how you can collect sensor data, how you can communicate between two devices, you know, things like that. Even at home, okay, if you already have Wi-Fi in the house, try to use, you know, services like if this then that, to say that anytime I connect to my home Wi-Fi, maybe send me an email. Okay, those are basic IoT things. But I mean, we can completely talk about getting started in IoT as a complete like session.
Yeah. So maybe we'll set another time, and then we would call you back to give us getting started about all these things, so that people can see how they can progress in terms of career options.
Yeah.
I have two hands up.
Sure.
I have Abba and Michael. So Abba, take it up from there. Abba, we are ready for you, please. Okay, if Abba is on there, please let's have Michael.
All right, thank you very much, sir. Mr. Samuel,
yeah.
Growing up, I become an IT technician because I love to explore like everything about IT. Now I've done my networking, I've done CCNA, I've done a little bit of RF, that's radio frequency, and I'm into security now, like specifically CCTV, electric fencing, like access points. Getting started I followed the whole session of this IoT thing. How do I start? Like from where I stand now, how do I start all this? Because I'm a bit confused about this whole thing, but trying to cope from the beginning. So how do I start, please?
Don't be confused. You actually even already have the basics of, you know, most things that others don't have. Disclaimer: I didn't come from an electronics or electrical or networking background. I was just the regular Joe who liked to break things and got a lot of lashes for it when I was growing up. But what intrigued me was the fact that I could connect the physical thing to like the tech or digital world. That is what fascinated. That was what drew me to it. In your case, there are a lot of applications in your space. So I always advise people that when you're picking, let's say, a new career, okay, or if you're picking a new stuff to do, take a look at how it affects your immediate surroundings or immediate use case. In your situation, you're already into networking and fencing and all CCTV and all that. All right. Have you looked at, okay, what happens now? It's IoT is there, but I might probably not notice it. What happens if an alarm is triggered? Is an SMS sent? That is IoT. What happens if there's motion detected? Is an SMS sent? Is the police called? Does it send a text message? Does it turn on the alarm? That is IoT in play. So don't look too far. Where around you, there's IoT in play in our everyday lives, but just that we've not seemed to focus or now paid attention to say, oh, this is IoT. So again, in your security fence, if the wires or the alarms are triggered, what happens? Do you send a text message to the user? Do you just sound an alarm? All right, those are IoT. So think about it. In the event where, let's say, I'm out of my home and I've armed my security system. If it detects a motion, something like this is happening. Let me go back here. Let's assume that this data that is sending, let's say, motion detected in the hall. This is being sent to the cloud. All right. This can now come onto my smartphone, and then this can be passed to an AI module, or this can be sent that, okay, anytime there is continuous motion for, let's say, 5 minutes in my house, when I have armed the house, send a message to the police. Do you get a scenario? That is IoT. So don't be confused. Right from where you are, there's already an IoT scenario. So start exploring the connectivity or IoT technologies within your area of specialty. I think that would be the easiest way to break the barrier.
Yeah, so can we maybe say next week Friday you take us through get started, so that some basic materials that people need to look at, some basic component that people need to get. So I'm having this webinar in my
I would have to check my calendar because
no,
it's quite
next
packed.
Friday. next Friday is just an example. Just an example. Anytime that you are free.
Okay, sure.
Okay.
Yeah, we can have a good schedule for that.
Yeah. So I mean, we are having this webinar here. My son is with me here. He's been playing with Arduino, so he's able to, understand and follow some of the conversation. But maybe somebody does not know how this circuit even looked like, So if we demystify, like the way you want us to demystify technology, if we demystify this by showing some of these things that ordinarily they will see in town and walk past, they will begin to pay particular attention to them, and then we can take it from there. Maybe some basic use cases and some demos that you've done now will be some good things that people can see and get really, really interested. I think that these are the things that are going to be of great importance to us in the next decade, and people need to learn them now, get the understanding now so that they can participate in this, emerging technology world where we get over all our COVID-19 and our conspiracy theories and everything. Life will become real and we will begin to use it, Yeah. Okay. All right. Do we have any more questions? Because we are hitting our 2-hour mark. We'll be glad to have a session on YouTube. You may alert participants to that effect. We have this recorded and we are going to put it on YouTube and we'll share with our members. So don't worry, everything we've done here is being recorded and go onto YouTube.
And those that are interested, like I mentioned when I started, I do a stream on IoT every Tuesday at 8 p.m. GMT. Every Tuesday, 8 p.m. I do something on IoT. And I have all of them recorded also on my YouTube channel. So if you look down here, my YouTube channel and everything is there. If you go to any of those links, you can watch all the videos I've done. And I've done some introduction to connecting sensors and all that. So you can check that out.
Yeah. So please take note of this. So you can connect YouTube and all the other channels, and then you can, come get closer to what we are doing. The time for preparation is now. The results will be seen in the next 5 to 10 years. So please take advantage of it. Cyril, you still have a question to ask?
10 years is too far.
Yeah, I was going to say the same thing. It's far. Yeah, this is actually happening now.
Please.
Well,
okay,
I
please,
know the way we embrace technology. It takes a decade for us to embrace it. I tell you. Right. Somebody also wants to ask a question. Please go ahead.
Okay, please. I wanted to know if we can have access to some short videos, like how you were able to link your codes with the hardware. So something like maybe I wrote a simple code, maybe just to implement some sounds, maybe say hello or something. Then how to link maybe my hardware with the codes. And also if you can get some email or something that we can channel our questions to you or something.
So I mentioned that if you look, I don't know if you can still see the screen you are seeing now.
Yeah, if you see the screen,
look down there, I have videos. I've created videos on my YouTube channel down there. So if you go to my YouTube channel now and go to the IoT Tuesday show, I have done several of those there. If you have any questions, either my website or you can hit me on Twitter or Facebook, any of it, I'll respond.
Okay, thank you very much.
Good. Thank you very much, Samuel, for your time and then the valuable information that you've shared with us today. It's really, really an eye-opener. And I think we'll continue the conversation where individuals will connect with you, but we'll try and work out a time where we'll come back to do, let's get started with IoT into the details. Thank you. Thanks to all participants. We're going off now the recording, and then if you have anything you want to chat with, you can. Thank you very, very much.
Thank you.